Hello everyone, welcome back to our channel. Let's discuss the very important topic, that is IUPAC nomenclature of organic compounds. Dear aspirants, you all are worried about how to name a particular organic compound by using the different set of rules which were framed by the IUPAC, International Union of Pure and Applied Chemistry. Let's discuss the nomenclature of different kinds of the organic compounds in a simple manner. For that purpose, we are having some particular rules. If you have those rules, you can easily write the name of the structure, right? Let's see. If you see the syntax, what we are observing? Prefix, root word, primary suffix and secondary suffix. So 1, 2, 3 and 4. 4 terms are present in this particular syntax. What is the first one? Prefix. Second one, root word. Third one, primary suffix. And the fourth one, secondary suffix. Just you should have the information related to these 4 components. If you have this information, you can easily write the name of the structure. Let's see how can we easily predict the name of the structure. What is the first component? Prefix. Simply remember, prefix means substituent. What kind of substituent is present at the carbon chain of a organic compound? Sometimes we may have single substituent, sometimes we may have more than one substituent. It may be 1, 2, 3, 4, etc., etc. So depending upon the type of the substituent, we can use di, tri, tetra, like that. So what are the groups which are generally used as a substituents? What are those? X means halo, Cl, Br, F, I. Nowadays we are using the fluorine, chlorine, bromine, iodine. Right? If you write, if it is a fluorine, you can write fluoro. It is chlorine means chloro. Bromine means bromo. Iodine means iodo. Simply, the general representation is what? Halo. If you have NO2 group, that is nitro. NO means nitroso. R means alkyl. Methyl, ethyl, propyl, isopropyl, secondary butyl. In that way, we can write the R group. Next one, OR, alkoxy group. OCH3. CH3 means what? Methyl. OCH3 means methoxy, ethoxy, propoxy. In that way, we can write the name of the substituent. Next one, if we have OH, that is going to become hydroxy. If you have N double bond N, that will become azo. These are some of the simple groups which will be used as substituents in the organic compounds. Simple. Halo, nitro, nitroso, alkyl, alkoxy, hydroxy and azo. What is the second portion? That is root word. This is very, very important. We all know that organic chemistry is also called as carbon chemistry. Why? Because carbon is the main element in every kind of organic compound or not. We are simply observing carbon chains. That's why our main focus is going to be the identification of the carbon chain. How many number of carbons are present in a particular organic compound? The root word indicates the number of carbons. How many carbons are present in the organic compound? If 1 carbon is present, that is meth. 2 carbons present, eth. 3 carbons, prop. 4 means but. 5 means pent. 6 means hex. 7 means hept. 8 means oct. 9 means non. 10 means dec. As far as the competitive examinations are concerned, we are going to have the different kinds of questions up to 10 carbons. So you need to focus the compounds which are having only 10 carbons. More than that, need not to worry. Okay, simply the first one is what? Substituent, that is commonly called as prefix. Second one is root word. Prefix indicates type of substituent present at the organic compound. Root word indicates how many number of carbons are present in the organic compound. The second one. The third one, primary suffix. This is very, very important. Primary suffix indicates the saturation or unsaturation present in the molecule. In simple words, saturation means what? Compound containing carbon-carbon sigma bonds. Unsaturation means it may be a carbon-carbon pi bond, that is double bond, or it may be a triple bond. So if you observe simple carbon-carbon single bond, that is saturated compound. That's why we need to write ANE. If you have carbon-carbon double bond, we need to write ENE. If we have triple bond, we need to write YNE. The primary suffix indicating what? It may be a saturated compound, so the name of the compound is ending with ANE. If it is alkene, name of the compound ending with ENE. If it is alkyne, name of the compound ending with YNE. Sometimes what happens in organic compounds, we may have more than one double bond or more than one triple bond. If you have more than one double bond or triple bond, we need to use di, tri, tetra like that. Okay, simply primary suffix indicates the saturation or unsaturation present in the molecule. Okay. The next one is what? Secondary suffix. This is very, very, very important. The secondary suffix indicates the type of functional group. We all know that different kinds of the functional groups are present in organic compounds. What are those? Alcohols, aldehydes, esters, carboxylic acids, amides, nitro compounds, nitriles, isonitriles. Like that we have a series of organic compounds or not. So based upon the functional group, organic compounds are divided into many types. So before going to have a particular nomenclature, each and every aspirant should have the particular information related to the functional groups. What are the functional groups which are nowadays available in organic compounds? If you know the type of the functional group, you can easily write the nomenclature. See this one. Suppose if the functional group is alcohol, name of the compound ending with OLO. Carboxylic acid means oic acid. Ester means name of the compound ending with O8. Aldehyde means AL-ol. Sulfonic group means sulfonic acid. Amine means same, amine. Ketone means one. Cyanide means nitrile. Amide means amide. If you have isocyanide, isonitriles. So these are the major functional groups which we are observing in different kinds of the organic compounds. That's it. Prefix, root word, primary suffix, secondary suffix. Just to follow these guidelines. If you know these guidelines, you can easily write the structure of the compound. 100%. What is the first one? Prefix. Prefix indicates type of the substituent. Root word indicates number of carbon atoms. Primary suffix indicates whether it is a saturated compound or unsaturated compound. Secondary suffix indicates type of the functional. Okay. Next one. Here we have some of the rules. We need not to discuss all the rules. Just whatever the important rules we are having, those rules are enough to determine the name of the compound. Okay. What is the first one? Longest chain rule. What the people are saying, initially whenever you want to write a nomenclature of any kind of organic compound, you should know longest chain rule. According to longest chain rule, we need to identify lengthy carbon chain. Okay. Next one. numbering of the carbon atoms. Simply the trick is, whatever the functional group we are having in the molecule, that functional group should get least number. Okay, suppose we have carbon chain of 10 carbons. We have one OH group at third position. That OH group should get the least number. OH means alcohol or not. If you have COOH, that should get the least number. That is numbering of carbon chains. Next one is what? Alphabetical order of substituents. Suppose you have a compound, the compound containing both bromine and methyl. Two groups are available. So the bromine starting with B or not, methyl starting with M or not. So if you arrange these groups in alphabetical order, bromine will come first, methyl will come last. Okay. These are the three rules we need to identify. Identification of the lengthy carbon chain, numbering as per the functional group. Third one, identification of the substituents according to the alphabetical order. Okay. If you see this particular situation, principal functional group order. Sometimes what happens in organic compounds, the compounds may have more than one functional group. If you have more than one functional group in a particular organic compound, how can we give the nomenclature? Always remember one thing, in any kind of the organic compound, only one group will be considered as the main functional group, remaining all will be considered as substituents. So, this is the order of the groups. Suppose assume that in your organic compound, you are having one aldehyde and a ketone. Both groups are present. The aldehyde will be considered as the main functional group. The ketone will be considered as the substituent. If the ketone is a functional group, the name of the compound will be ending with ONE, one. If the same ketone is the substituent, what should we do? We need to write oxo or ketone. In such a way, we need to identify the different kinds of the substituents which are present at the carbon chain of different kinds of organic compounds. Let us see some of the examples. In the first example, what we are observing, first one is the what? Lengthy carbon chain. Whenever you give the numbering to a particular carbon chain, we need to keep it in mind that whatever the functional group or unsaturation which we are having, the unsaturation or the functional group must be having the least number. See this one. If you start the numbering from the left side to right side, the unsaturation is going to take the number 2. If we will give the numbering from the right side to left side, what will happen? 1, 2, 3, 4, 5. The unsaturation is going to get the number 5 or not? But in the first case, number 2. So 2 is the lowest number or not? That's why the numbering from left to right will be always the correct one. Simply keep it in mind. Whenever you have the unsaturation must be having the least number. If you have the functional group should have least number. Okay. The second one is what? Numbering of the carbon atoms. The third one, alphabetical order of the substituent. If you have more than one substituent, depending upon the alphabetical letter, we can arrange them. You have given the numbering, right? What is the syntax? Prefix, root word, primary suffix and secondary suffix. Primary suffix indicates that type of the substituent or not. If you see the molecule, we have two methyl groups or not. Methyl groups are the substituent. So the prefix will be what? Methyl. How many methyls are there? Two methyl groups are there. That's why it will become what? Dimethyl. Then what are the positions of the substituents? 4th position and 6th position. That we need to consider. Okay, always the first component is what? Prefix. Prefix indicates the type of the substituent. How many number of substituents are present along with their numbering or their positions we need to write. So this portion is prefix. After the prefix, root word. Root word indicates number of carbons present in the particular longer chain or not. See how many number of carbons are present. 7 carbons are present or not. 7 carbons means what should we write? That will become hept. Hept plus primary suffix. Primary suffix indicates the unsaturation or the saturation present in the molecule. If you observe this molecule, we are having carbon-carbon pi bond or not? Carbon-carbon double bond or not? So carbon-carbon double bond means what will be the primary suffix? The primary suffix will be ene. So hept plus ene. Then what is the position of the double bond? That is second one or not? 2-ene. Plus next one, secondary suffix. Secondary suffix indicates type of the functional group. Do we have any kind of the functional group here? No. So that component will become 0. So what will be the name of the compound? 4,6 dimethyl hept2-ene. See the second example. In case of the second example, we are observing carbon-carbon triple bond or not? That is the first case. Second one, do we have any kind of the functional group? There is no functional group. That's why secondary suffix will be what? 0. Triple bond is present means suffix will be what? Ine or not? What is the position? Second. 2-ine. Number of carbons how many? 6 means hex. Any substituent? No. The prefix will be 0. So the name of the compound is hex2-ine. The next example. In the next example, we are having one methyl group and 2 triple bonds. What is the position of the methyl group? 3. So prefix will be what? 3-methyl. Number of carbons how many? 5. So pent. Triple bond means ine. How many triple bonds are present? 2 or not? So di-ine. What are the positions? First one and fourth one. 1,4 di-ine. Plus no functional group means secondary suffix will be 0. So let's continue some more examples related to this particular nomenclature. See the next one. In this particular molecule, what we are observing? COOH. It is a main functional group or not? COOH means carboxylic acids. So whenever we have a functional group, that functional group should have least number or not? That's why the numbering is starting from this carbon only. 1, 2, 3, 4. At the third position we are having what? One substituent. So according to syntax, first we need to write prefix. What will be the prefix? That is methyl. What is the position? Third position or not? So 3-methyl plus root word. How many carbons are present? 4 carbons are present or not? 4 carbons means bute. Plus primary suffix. Primary suffix indicates the saturation or unsaturation. If you see this particular molecule, this molecule is containing carbon-carbon single bonds or not? So saturation observed. For the saturation for carbon-carbon single bond, what should we write? That is ANE. The secondary suffix is what? Functional group. What is the functional group? Carboxylic acid or not? If carboxylic acid is present, the name of the compound is ending with oic acid. While combining all the words to write the final nomenclature, see this one. In case of the saturation or unsaturation, whatever the last letter which we are getting, that should be omitted. So while writing the final name, what should we omit? E. So combine all the words. 3-methyl butanoic acid. Very simple or not? Next example. In the next example, we are observing C double bond OCl. C double bond OCl means acid chloride or not. So acid chloride is present. It is a functional group. That's why it should get the least number. So numbering starting with this particular C double bond 1, 2, 3, 4. The second position containing bromine. Bromine means bromo. So what will be the prefix? 2-bromo plus root word, number of carbons how many? 4. 4 means but. Next one, all are carbon-carbon single bonds or not? I am talking about the carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond. Not the carbon heteroatom pi bond. In this molecule we are observing what? Carbon-oxygen double bond. But we are concentrating on only carbon-carbon bonds. Carbon-carbon single bond, carbon-carbon double bond and carbon-carbon triple bond. So, all are carbon-carbon single bonds or not. That's why the primary suffix will be ane. So, acid chloride. So, what will be the secondary suffix? OL chloride. So, in order to combine all the words, what should we omit? The last letter of the saturation or unsaturation. So what will be the name? 2-bromo-butanoyl chloride. Simply omit E. Next example. If you see this particular example, we are having C double bond O and OH. C double bond O means ketone, OH means alcohol. So this molecule containing two functional groups are not. So whenever we are having two functional groups, we need to follow the order or not. Why? Because in any kind of the organic molecule, the primary functional group must be a single one. Remaining all will be considered as substituents or not. So in case of ketone and this particular alcohol group, if you have the competition according to the order, the ketone will be considered as the primary functional group. The OH will be considered as substituent. If the OH is substituent, how can we write? Hydroxy. Already we know that. C double bond O is the main functional group. That's why the main functional group should get least number or not. Always. So numbering always starting from the left to right. Thereby the C double bond O will get the less number. So 1, 2, 3, 4, 5. Okay. Now the first component is prefix or not. Prefix indicates type of the substituent. So how many substituents are present? If you see this example, at the fourth position we have one hydroxy group and one methyl group. Two substituents are present or not at the same position. But what should we identify? The first letter of the word. According to the alphabetical order, which letter will come first? H or M? H will come first or not? That's why 4-hydroxy, 4-methyl. At fourth position we have two groups, 4-hydroxy and 4-methyl. This will become your first portion prefix. The second one is what? Root word. Root word indicates number of carbons. How many? 5 carbons or not? 5 carbons means pent. What is the position of C double bond O? Second or not? So 2 pent plus, do we have any pi bonds? No. All are carbon-carbon single bonds. That's why the primary suffix will be ane, ane. Then functional group is ketone or not? If the ketone is functional group, what will be the secondary suffix? one, one. So by combining all these, what should we omit? The last letter of the saturation or unsaturation. So the name of the compound will be 4-hydroxy, 4-methyl, 2-pentanone. See the next example. In this particular example, we are observing OH and alkyl groups. So OH is the main functional group. That's why the the secondary suffix will be OL, ol or not. So alcohol is the functional group. So the OH attached carbon must be having least number. So 1, 2, 3. Remaining same procedure. 1, 2, 3 methyl groups are present. What are the positions? 2, 3, 4. 3 methyl groups. That's why trimethyl. Plus number of carbons 6 means heads. All are carbon-carbon single bonds. N. OH is the main functional group. So secondary suffix will be OL, ol. What is the position? Third position. So 3 ol. Omit E, thereby you will get the final name. Next example. In this example, we are observing two functional groups. One is COOH, another one is CHO. Both are the functional groups or not? So, in this case, which one will be the main functional group? You need to follow that order. According to the order, the COOH will be considered as the main functional group. So CHO will become substituent or not? If the CHO will become substituent, how can we write? Formyl. So the numbering should be starting from what? COOH or not? Why? Because the principal functional group should have least number. So 1, 2, 3, 4. The fourth position containing formyl group, third position containing methyl group. Which one will come first? Formyl or methyl? Formyl or not? So 4 formyl, 3 methyl plus number of carbons how many? 4 carbons or not? So bute. All are carbon-carbon single bonds. That's why N. COOH means the secondary suffix will be oic acid. So simply omit E, thereby you will get the final name. Okay. Next example. So this example is somewhat complex than the previous examples or not. See, carbon chain length is 8. Different substituents are present. One CHO is also present. The CHO will be the main functional group or not? The CHO will get least number. That's why the numbering starting from this carbon only. So from the right to left. So how many groups are present? At the third position, OCH3, that is methoxy. Fifth position, Cl, that is chloro. Seventh position, OH, that is hydroxy. So among these three, which one will come first? Chloro or not? C letter. CHM. C. 5 chloro, 7 hydroxy, 3 methoxy. Plus number of carbons how many? 8 or not? 8 means oct. Plus primary suffix will be saturation or unsaturation. If you see this molecule, we have a pi bond or not? Carbon-carbon double bond means we should write ENE. What is the position? Fifth position or not? 5-ene. Plus secondary suffix is aldehyde or not? So aldehyde means name of the compound ending with AL, all. Omit E. Thereby you will get the final name. Okay. Next example. Here also similar kind. CHO is the main one. So the numbering should be starting from this carbon only. So 1 to 8. Third position methyl group. Seventh position methyl group. So 2 methyl groups. 3, 7 dimethyl. Plus 8 carbons means octa. Now see this particular one. We need to identify saturation or unsaturation. Here we are observing how many pi bonds? 2 pi bonds or not? Pi bond means in. 2 pi bond means di. What are the positions? Second and 6. So 2, 6 di-ene plus aldehyde means Al, all. Remove or omit E, thereby you will get the final name. See this particular example. This one containing major number of substituents. If you will identify the name of this particular compound, you can easily write the nomenclature to any kind of compound. Okay. Let's see this particular example. The first one is what? Identification of the carbon chain, length here carbon chain. Second one, identification of functional groups and substituents. If you identify this particular molecule, one is CHO. CHO means it is a functional group. Second one is OH. It is also a functional group. Next one, CN. It is also a functional group. So, nitriles are present, aldehydes are present, alcohols are present. So three different types of functional groups are present. So, according to the rules, only one functional group will be the main functional group or not. If you see the order, according to the order, the majority should be given to the what? Nitrile. Nitrile will be considered as the major functional group. If CN will be the major functional group, the secondary suffix will be nitrile or not. So the remaining two will be considered as what? Substituents or not. So if it is the substituent, it will become what? Formyl. If it is the substituent, how can we write? Let us see. We all know that CH3 means methyl or not. If you replace one hydrogen with chlorine, how can we write? Chloromethyl. Second position, see, chloromethyl. Next one, NH2 means amino, amines, or NH2, amino. If you observe this particular nitrogen, the nitrogen connected to two methyl groups or not? NH2 means amino. Two hydrogens replaced with two methyl groups. So how can we write? NN dimethyl amino. Two methyl groups are connecting the same nitrogen or not? That's why we are using the word N comma N. 2 means dimethyl amino. This is the derivative of the NH2 or not? So N comma N dimethyl amino. Similarly, CH3 means methyl. One hydrogen is replaced with OH. OH means hydroxy or not? So hydroxymethyl. NO means nitroso. CHO means formyl. CH3 means methyl. If you put oxygen, methoxy. Methoxy. So we need to arrange all by using the alphabetical order. So according to alphabetical order, we are getting these groups. Okay, up to this, all are the substituents only. All the substituents are considered as what? Prefix or not? So prefix plus root word. How many carbons are present? 9 or not? So 9 means known. Do we have any kind of the unsaturation? Yes. At 8th position we have a pi bond. Carbon-carbon double bond. Double bond means ENE, ene. What is the position? 8th position. 8 ene plus what is the functional group? CN. So the secondary suffix will be nitrile or not? What is the position? First position. 1 nitrile. Simply omit E and write the name. I think this example is very clear. If you are able to give the nomenclature to this moiety, so you can write the nomenclature of any kind of the organic. Let's take one more example. Here what we are observing, COOCH3 means it is a ester or not? The representation of ester is what? RCOOR. Right? So till now we have identified this kind of moiety. In case of carboxylic acids, R is replaced with hydrogen, COOH. In case of acid halides, R is replaced with simply OR is replaced with ClBr. Already we have seen the examples. Suppose if you have the ester moiety, that will become the major or principal functional group. remaining will become the substituents as per the priority order. You all need to remember one thing. This portion is the main portion. Along with the main portion we are having what? One simple R group or not. So whenever we write the name of any kind of the ester, first write the name of this R. Then continue your syntax. See this moiety. What is this R? CH3 or not? CH3 means, what is the name? Methyl. So before starting the name of this particular ester, what should I write first? Methyl. Then follow your syntax. According to syntax, substituents. What is the substituent? At the second position, ethyl group is present. Total number of carbons 4 means but. All are carbon-carbon single bonds means ane. Ester means the secondary suffix will be O8. So omit E. So methyl to ethyl butanoate. Okay. The last example. In this case also, ester moiety or not? So what is the R? C2H5. C2H5 means ethyl. So before writing the name, what should I write first? Ethyl. Then follow the order. If you observe, here we have keto group or not? C double bond O. Ester and keto both are present. Ester will become the primary functional group. The C double bond O will become the substituent. If the C double bond O is substituent, what should we write? Oxo or keto we need to use. Okay, remaining all the similar things. So if you observe this particular group, what is this group? We all know that CH3, CH2, CH3. This is propane or not? According to the structure. Is it have any substituents? No substituents means prefix 0. Number of carbons how many? 3. 3 means prop. 3 means prop. All are the single bonds. Single bond means ane. So what is the name? Propane. Suppose if you remove hydrogen from this carbon and hydrogen from this carbon and connect these two, that is cyclopropane. This is cyclopropane. Hydrocarbon representation is RH. If you remove H, that is alkyl or not? Alkane. Remove hydrogen. Alkyl. Alkene. Remove hydrogen. Alkenyl. Alkyne. Remove hydrogen. Alkynyl. Similarly, cyclopropane. It is an example of cycloalkane or not? From that remove one hydrogen. What will happen? Cyclopropyl. From the propane remove one hydrogen. Propyl. From the cyclopropane remove the hydrogen. Cyclopropyl. So this will become what? Cyclopropyl. Cyclopropyl. So in this way we can have the nomenclature of any kind of organic compounds by using the simple syntax. Prefix means type and position of the substituent. Root word, number of carbons. Primary suffix, saturation or unsaturation. Secondary suffix, your functional. Right? I think this video is very helpful to all of you for the identification of the name of any kind of the simple organic compounds.